All right, welcome back, everybody. So we are going to prove the second fundamental theorem of calculus. So if we let, don't need a dt there. We're going to define a function f prime of t. So capital F prime, you could do lowercase as well. So capital F prime of t is a continuous function on AB. Then the integral from a to b of f prime of t dt is f of b minus f of a, where f is the antiderivative of f prime. Okay, so let's go ahead and get started on this one. So we'll get our proof here. And we're going to start right off by using that first fundamental theorem that we proved last time. So we're going to define a function g of x equal to the integral from a to x of f prime of t dt. And we know that by our first fundamental theorem of calculus, g prime of x is equal to f prime of x. Okay, so that's very useful, because now if we think about if I were to integrate both sides indefinitely, that means that g of x is equal to f of x, the antiderivative of f plus c. Right? They differ by a constant because their slopes are the same for all x. Should be a little bit more formal here, where x is an element of AB. Sorry. Yeah, so x is going to be within our continuous interval, obviously. All right, so this is good. And note this is going to be true for all x. Right, so for all x in our interval. So let's play around with this a little bit. Okay, so we can put however. Let's note, so g of a, which is the integral from a to a of f prime t dt, is equal to 0. Okay. And so what that's going to mean is, so if I call this 1, call this 2, so by 1 then, we know that g of a is equal to f of a plus c, but this is just 0. So what that means is that c is equal to the opposite of f of a. Right, so we know whatever the constant is, it's going to be the opposite of the antiderivative at our left endpoint of the function. So that's definitely something we're going to need to use. We'll call that 3. All right, so what else can we do then? Oh, well, why don't we think about g of b. So g of b is going to be f of b plus c. So g of b, though, is f of b minus f of a. But f of b minus f of a, right, that's what we were looking for, is g of b. And note g is the integral from a to b of f prime of t dt. And we're done. So much shorter proof once we have that first fundamental theorem. So let's zoom in a little bit. Yep. So that's a quick little proof. Again, still pretty informal with the epsilon delta sort of scenarios of things, but a proof nonetheless. So FTC2, FTC1 are all here, and hope you enjoyed. So if you have questions, let me know. Otherwise,